Have you ever wondered how quantum technology might change our world? Imagine a technology so powerful that it can solve complex problems in the blink of an eye. A technology that has the potential to revolutionize our world as we know it. This is quantum technology, a realm where the laws of physics as we understand them are twisted and turned on their heads. In the simplest terms, quantum technology leverages the peculiar properties of quantum mechanics, such as superposition and entanglement, to perform tasks that are currently deemed impossible. Picture a world where traffic jams are a thing of the past, where diseases are diagnosed even before they manifest, where our data is safer than ever. From healthcare to transportation, from cybersecurity to finance, quantum technology could have a profound impact on various sectors of society. It's like opening a door to a world of limitless possibilities. Now that we have a basic understanding of what quantum technology is, let's delve deeper into its applications. Imagine a computer so powerful it could solve problems beyond the reach of traditional computers. Welcome to the world of quantum computers, a realm where the bizarre rules of quantum physics are harnessed to create a new breed of supercomputers. But what is quantum computing? In the simplest terms, quantum computing is the use of quantum bits, or qubits, instead of the usual binary bits used in traditional computing. Let's break that down. A traditional computer bit is either a 0 or a 1. It's like a light switch that can be either on or off. But a qubit? It's more like a dimmer switch. It can be on, off, or any state in between thanks to a quantum property called superposition. Superposition allows a quantum computer to process a vast number of possibilities all at once, but that's not all. Quantum computers also utilize another quantum concept known as entanglement. If two qubits become entangled, the state of one instantly influences the state of the other, no matter how far apart they are. This entanglement, combined with superposition, allows quantum computers to process information in ways that are simply not possible with traditional computers. Now, what does this all mean for the future of computing? The potential of quantum computers is mind-boggling. They could tackle complex problems that would take our current computers millions of years to solve. They could revolutionize fields like cryptography, material science, drug discovery, artificial intelligence, and so much more. But it's not all rosy. Quantum computers are still in their infancy. They are challenging to build and maintain, and their results are often filled with errors. They also require conditions colder than deep space to function. But the race is on. Tech giants and startups alike are pouring billions into quantum research, hoping to overcome these hurdles and unlock the full potential of this technology. Quantum computers promise to revolutionize how we solve problems. But what about how we store data? The answer to that question may lie in the realm of quantum storage, a topic we'll dive into in our next scene. Stay tuned as we continue our journey into the quantum future. In a world where data is the new oil, imagine a storage system that could hold unimaginable amounts of information in a fraction of the space. Welcome to the concept of quantum storage, a thrilling frontier in the world of data management. To appreciate the possibilities of quantum storage, we need to start with the basics. Traditional computers use bits, the smallest unit of data, which can be either a 0 or a 1. Quantum computers, however, use quantum bits or qubits, which can be both a 0 and a 1 at the same time. This is due to a quantum phenomenon known as superposition. Let's take a moment to let that sink in. A qubit can hold more information than a traditional bit. Imagine a library where a book can be on every shelf at the same time. That's the power of a qubit. It is this ability to hold and process large amounts of data simultaneously that makes quantum storage so intriguing. But what does this mean for data centers, the warehouses of the digital age? Today's data centers are sprawling complexes, consuming vast amounts of energy and space. Now picture a future where quantum storage shrinks these behemoths down to a fraction of their current size while exponentially increasing their storage capacity. The implications are staggering. Not only could quantum storage dramatically reduce the physical footprint and energy consumption of data centers, but it could also supercharge their processing power. This could lead to breakthroughs in fields as diverse as climate modeling, pharmaceutical research, and artificial intelligence. However, it's important to note that we're still in the early days of quantum technology. There are significant challenges to overcome, from maintaining the stability of qubits to figuring out how to scale up these systems. Yet the potential rewards are too great to ignore. With the potential to store vast amounts of data, quantum storage could change the face of data centers. But how might quantum technology impact the world of finance? Imagine a financial system so secure it's virtually impossible to hack. Welcome to the world of quantum blockchain. This isn't just a buzzword, it's the fusion of two cutting-edge technologies, quantum computing and blockchain. Together, they form an unbreakable chain, a new frontier in the realm of financial security and efficiency. So, what exactly is quantum blockchain? At its core, it utilizes the principles of quantum mechanics to enhance the security and efficiency of blockchain networks. With quantum computing's immense processing power and the inherent security of blockchain, we have a system that is not only faster and more efficient, but also near impenetrable. How does it work? Quantum blockchain employs quantum key distribution, a method that uses quantum states to encrypt and decrypt data, making it nearly impossible for unauthorized parties to access. This level of security surpasses anything we've seen in classical computing. Moreover, quantum blockchain doesn't just stop at security. It also addresses one of the biggest criticisms of traditional blockchain, the issue of scalability. Quantum computing's ability to process vast amounts of data in parallel means transactions can be verified and added to the blockchain at a much quicker rate. This could be the key to making blockchain more viable for large-scale applications. Now let's talk about the potential impact on the financial sector. Imagine instant secure transactions, unaffected by distance or volume. This could revolutionize everything from banking to insurance, from stock trading to real estate. It would mean more efficient markets, lower costs, and greater trust. But it's not just finance. The principles of quantum blockchain could be applied to any industry that relies on secure, efficient data management. We could see quantum blockchain securing our medical records, our votes, even our identities. The implications are vast and exciting. Yet, like any technology, quantum blockchain also brings challenges. It's a field in its infancy, and there are technical and ethical hurdles to overcome. But the potential rewards, they're enormous. Quantum technology promises to revolutionize many aspects of our lives, from how we compute, to how we store data, to how we transact financially. Quantum blockchain is just one piece of this puzzle, but it's a piece that could redefine the way we think about security and efficiency. So are we on the brink of a quantum revolution? Quantum technology, with its immense power and potential, stands poised to redefine our world. Quantum computers, promising unparalleled processing speeds, quantum storage, heralding a new era of data centers, and quantum blockchain, the unbreakable chain, are all part of this tantalizing future. Each holds the potential to transform sectors across society. Only time will tell how quantum technology will reshape our world. But one thing is for certain, the future is quantum.